Hi, so this is my video presentation for graphing rational expressions, and the equation I chose was number 67 on page 287 of our pre-calculus textbook, and that problem was x to the fourth minus 20x squared plus 64 all over x to the fourth minus 10x squared plus 9. So let's just go ahead. First thing we're going to do is factor this down further. In order to do this, we have to split the middle term up into two parts. So first part of doing that is it has to add up to a negative 20 and multiply to get a positive 64. This is going to be two negative numbers because two negatives equal a positive, and two negatives will add up to be a negative number. So let's go ahead and write x to the fourth, and these two numbers are going to end up being negative 16 and negative 4 because they will multiply to 64 and add to negative 20. So go ahead and separate those. Next, you're just going to use the grouping method. So take out x squared, and you'll be left with x squared minus 16. And then out of the second term, just go ahead and take out a negative 4. You'll end up with x squared minus 16 once again. So take those two and put them into two separate factors. So you're going to have x squared minus 4 and x squared minus 16. Those can be broken down even further into x minus 2 and x plus 2. And for x squared minus 16, x minus 4, and x plus 4. So right there is your numerator, so I'm going to go ahead and put that right here. So now we're going to do that exact same process, but for the denominator. So I'm going to go ahead and separate these, write the x4, and here they have to multiply to a positive 9 and add to a negative 10. So like I said before, this is going to be two negative numbers. So these two are going to be a negative 9. So that's going to be negative 9x squared and negative 1. So negative x squared plus 9. And that's going to add up to negative 10 and multiply to 9. And then if you take out the x squared here, so use the grouping method, you're going to end up with x squared minus 9. And take out a negative 1 out of this second term, and you'll end up with x squared minus 9 once again. Put those into your separate groups, x squared minus 1 and x squared minus 9. Once again, those two can be factored again, and you get x minus 1, x plus 1. And for x squared minus 9, x minus 3, x plus 3. So I'm going to go ahead and put that on the bottom. The first thing to do after this, kind of the first thing to start graphing, is to find the domain. And the domain comes from where the denominator equals 0. So you're going to start with the smallest number and work to the biggest one, because when you're reading a graph, you're going to go from left to right. So the smallest number is going to be negative infinity, but that's not when one of these will equal 0. That's going to be a negative 3. So you're going to have negative infinity to negative 3. Union, because you want to separate those terms, because your graph is never actually going to touch any one of these values. And then you're going to have negative 3 to negative 1, union negative 1 to 1, union 1 to 3, and finally union 3 to infinity. So here would be where we would cancel out any terms, but there's nothing here to cancel out. So basically what that means is we're not going to have any holes in our graphs, and all of these values in the denominator are going to be vertical asymptotes. But before that, let's go ahead and find our x-intercepts, which is where the numerator equals 0. So first you're going to have 2, 0, and that comes from here, negative 2, 0, 4, 0, and negative 4, 0. And this 0 comes from where it will lie as far as your y value goes. So that's going to be 0 since these are x-intercepts. Now, when looking for your y-intercept, which is where your x value is at 0, and the graph crosses the y-axis, you're going to go ahead and look at your original term and see what value you would have if you plugged in 0 for x. So that's going to be 64 over 9. So you have 0, 64 ninths. So now here is where we will find our vertical asymptote. Like I said, that comes from these values in the denominator. So you're going to have x equals -3, x equals -1, x equals 1, and x equals 3. And you're going to want to put x equals because that is how you're going to look at that line. And then next would be a horizontal asymptote. Horizontal asymptote depends on your highest exponent in the numerator compared to the highest exponent in the denominator. So in this case, they are both 4, so that's going to be the same. So you're basically going to do the ratio of the leading coefficients for the numerator over denominator, so just the ratio right there. So that's going to be 1, and since this is a horizontal line, you're going to put y equals 1. So here is where you are actually ready to go ahead and graph. Okay, so here's where you're going to go ahead and put your items from here that you can put onto the graph. So I'm going to use different colors for this part. So first step, I'm going to go ahead and put the x-intercepts. Let's use green for those. So you're going to have 2, 0 right here, -2, 0 here, 4, 0, and -4, 0. And then we can also put the y-intercept. 64 divided by 9 is a bit more than 7, so we can just call it 7-ish. So you're going to have 1, 2, 3, 4, 5, 6, 7. So that's going to be roughly right here. Like I said, it's 7-ish. So it's going to be like 7.11. Okay, next we're going to put our vertical asymptotes. So vertical asymptotes are at -3, -1, 1, and 3. And lastly, we have our horizontal asymptote, which is going to be at y equals 1. Now, whenever you're graphing, your graph actually can cross the horizontal asymptote if necessary. So more than likely here they will have to because there's an x-intercept here and here. But they can never ever cross the vertical asymptote. So if they do, you've done something wrong. Okay. So let's go ahead and make our sign line. Okay, so the numbers we put on our sign line are going to be our x-intercepts and our vertical asymptotes. So next step is to pick values in these intervals to plug back into our simplified equation to see if they get negative or positive answers. So I'm just going to write those numbers in blue, the ones we'll plug in. -5, -3.5, -2.5, -1.5. Let's put 0 here. 1.5, 2.5, 3.5, and 5. So first, if we put -5 in here, we're going to get a total of 8 negative numbers, which means this is actually going to be a positive because an even number, I'll write that in black, an even number of negatives will give you a positive and an odd number will give you negative. So there's nothing really weird going on here, so it's pretty safe to assume that they will alternate, but we can check just in case. So -3.5, they are all going to be negative again, except for this one here, and that's x plus 4. So -3.5 plus 4 is a positive number, but now that has made that into odd number of negatives, negative value. Negative 2.5 is going to keep this positive, but also have this become a positive as well, meaning we're back to 6 negatives, positive overall section. Negative 1.5, same thing going on here. You add this x plus 2 to the set of positives, meaning this now has 1, 2, 3, 4, 5 negatives overall negative section. Here at 0, those are pretty easy to plug in. You have negative here, positive, negative, positive, negative, positive, negative, positive. That is an even number of negatives, positive section. 1.5, you have those same 4 negatives, but you also lose one of these, this x minus 1 here. That is now going to be a positive value. So that means it's 3 negatives instead of 4, negative section. So 2.5, you're going to lose this x minus 2 as a negative value. That's going to become a positive. You then have 2 negatives, meaning positive section. 3.5, you're going to lose another one. You're going to lose this x minus 3. You now only have 1 negative value left, meaning negative section. 5, all 8 of these values are going to be positive, which means the overall equation is positive when you have any numbers above positive 4. So we can just start graphing this now. This entire section from here to here is to remain positive. So just going to take it from here, follow the line of that horizontal asymptote, come to here. Now this is negative, so here is where you can drop this down and go ahead and bring it down, make sure not to cross the vertical asymptote. Here, you start positive, come down to that. Like I said, you can touch this, come down to that x-intercept, and now it's going to become negative, swing down, and there you go. Next section, this is an entire positive section, which means it is not going to cross the x-intercept at all, and more than likely it won't cross the horizontal either because you don't have to. And also, we need to make sure we cross that y-intercept here. So you're just going to go ahead and put that there. And this section is going to be a negative section. So instead of starting up here, we're going to start down here, work up to that x-intercept, and here it becomes positive. Go ahead and move that up. And finally, you have this section. This whole thing is going to be negative, so go ahead and pull it up to that x-intercept, and then cross over that axis because you have positive here. And there is your graph. Oh, and before I forget, the word of the day is parakeet.